Go ahead, Thomas.
Hi, teacher me.
Hi, Kevin.
So we found here on the coefficient of kinetic friction stopping the car. Okay, and I've stressed to you guys, I explained to you there the importance of that coefficient of kinetic friction because we want kinetic friction happening between our tires and the road instead of static friction, because if we had static within it, then it would be a really, really bad situation, and explain the whole process of anti-braking systems and why we have those down where you cannot lock up your tires.
Yeah, buddy.
So now we will start.
Will we?
On some good stuff. So page 146. We are going to pick up on number 81. We're having much fun here, guys.
We show.
I hate your fun.
Yay.
I love my type of fun.
I'm so excited.
Can we have a work? All you need is a little crooked teeth and you'll be perfect.
I'm going to get one in this sheet. We're going to need a whole sheet for this.
I'm sorry, what?
What page are we on?
We're going to practically need a whole sheet for 81. That's 146.
Oh, gee.
A whole sheet?
Honored you.
Practically. Hey, have I stressed it to you now?
Yeah.
Alright, so an object in equilibrium has three forces exerting on it. Okay, so in this, the first force, a 33 Newton force, acts at 90 degrees from the x-axis.
Wait a minute.
A 44 Newton force acts at 60 degrees from the x-axis. Both angles are measured counterclockwise from the positive x-axis. What are the magnitude and the direction of the third force? So in this,
I thought we were just dealing with 2 dimensions.
we are.
There's 3 forces.
That don't matter.
That doesn't mean it's in 3 directions.
Oh my goodness.
You silly goose.
But isn't there
Tricks are for
technically?
kids.
Isn't there technically 4 directions?
You silly rabbit.
Yeah.
No, there's one
Fourth
direction.
No, I mean like not dimensions, but directions.
Left, right, up, down.
Up, down, left, right.
Northeast, southwest.
Dimensions, Dimensions. okay, are like axes. So you got x-axis, y-axis, and you have z-axis.
I got
But
you.
then whenever you break in the fourth dimension, which is what we're saying,
There's a-
I'm saying 1D is
there's
1
3D.
direction, 1 dimension. 2D is 2
2D.
dimensions. 3D is how we see our world in 3D, 3 dimensions. The fourth
So, up,
dimension
down,
is
side,
that
up.
of space and time.
Yeah,
many
but that
numbers
would
are
be 8 directions.
No.
1, 2, 3.
No, I'm talking like you see the arrows up there. There's 4 arrows.
Yeah, northeast,
So
southwest.
why wouldn't there be like 4 directions?
It's not 4 arrows.
Now, there's 4 vectors. Four
There
Four
are
lines,
there's
4
two.
rays.
4 rays.
Just because I have arrows on the end of these doesn't mean these are 2 rays. This is a line. The arrows show that it keeps going on forever and ever
No,
and
I'm
ever. It's
talking
not going
like
to
there's
stop.
normal force and then the
I haven't put
normal
any
force
forces
and
acting on this. We don't know the forces that are acting on it besides
and
the one
then
that are
there's
listed.
kinetic and static friction.
Okay, so whenever it says an object is in equilibrium with 3 forces acting on it, and they ask you to find the third force, I'll give you a hint. This isn't sitting on the ground. So there is no normal force. There is no force of friction.
That sucks. We have to do true.
So in this, we have a 33 Newton force that acts 90 degrees from the x-axis. So we have this force. And this is 33 newtons.
Yeah, buddy.
Alright, then we have force 2. That is 60 degrees from the x-axis, and it's 44 newtons.
It's going to be how much?
44 newtons. So it's 60 degrees,
Okay, now I
so
see
44
what you
newtons.
do.
Now in this, we're trying to find this third force. Now the thing that we know is that in this, our net force is equal to 0. We know that because it says it's at equilibrium. Therefore, it's not moving. So there is no motion. Since there is no motion, we know that all the forces are canceling out and nothing is accelerating it. So what we can do is something that you got to get really good at.
That was me.
We have to find the net forces between these two forces,
And
the
then
red
there's the
force and the
opposite.
green force, and then we're literally going to change them to the opposite direction. Then we will do some trig. We will find the value, that magnitude, and then we're going to find the degree, which is our direction.
Okay,
Yes.
is there any way?
Go ahead.
Is there any way you could like break down the trig for it? Cause like I just don't understand it at all.
Sure.
Okay.
Okay, so we have this first force, this red force, which is equal to 33 newtons. Now here's the good thing. They were very nice to us. Why? Because what direction is that in?
Directly up.
It's directly up. It's in the Y direction. So that means it's already set in the Y direction for us, so we don't got to worry about it. We don't have to do any trig to it because it sets on the A axis. But our second force is where the fun comes in.
No. I disagree. This is not fun. This is torture.
Okay, so we have this 44 Newton force that's at 60 degrees. From the positive x-axis, so here's this x-axis.
Wait, so we're going from that line? Or we're just
And then we
making,
have to.
are we just making another triangle?
I'm making the triangle is what I'm doing. It wasn't big enough for me to make a triangle up there. So this is the force of x in the x direction from this force. But then along with this, we have the force in the y direction of this. So now whenever we're looking at it, we're going to use this angle to figure out all our information here. So I'm going to start here with the force of x. Okay, so for this force, the x component of it, I'm going to go from this angle. It's going to be adjacent over hypotenuse. So f of x is equal to, sorry, I'm getting my neck pop. I've been trying all day.
Adjacent over hypotenuse.
I'm in the cosine 60 degrees.
What's
Is it, I was going to jump, but then all of y'all would have freaked out on me if I jumped.
What?
Yeah.
What?
Is equal to f sub x, which is the adjacent side,
Okay.
divided by the hypotenuse, which is the 44 newtons.
Well-
This is where I was going to jump, and I knew it would have went horribly wrong if I would have just wrote this down. F sub x equals 44 newtons times the cosine of 60 degrees.
Okay, wait.
If I would have wrote that, just wrote that down, you all would have had a heart attack, and you know.
Yeah, hello.
So everybody wants to start freaking out that I started breaking down. What's up, Logan?
So don't we have the force Y?
No,
Then
we
what's
have to
the,
find
Yeah,
it.
but how do
what's
you?
the 33 newtons then?
That's the second force. That's why I did it different colors. Force 1 is red. Force 2 is green. You have to break that second force into two components.
Okay.
It doesn't matter if it lines up going in the same direction. It doesn't make that force equal to it. That's a second, totally opposite force acting on it.
So say there's another scenario and we're not
I
given
get 22 newtons.
the angle.
I didn't get that.
Then I'll ask you to find it. Are you in degree or radians?
How do you change
Hold on,
that?
let me-
Go to mode. It's below, where's it? It's right here next to the second function. Once you click it, go down to where it's radian degree, make sure degree's highlighted.
So is 22 the bottom, or is it going to be?
That's the bottom, that's the force right here. That's why I did it in the black pen. Now do the force in Y. Whenever you do that, it's opposite of that angle, so that's the sine of 60 degrees is equal to the opposite, which is the force of Y divided by 44 newtons. So if you want to, you just jump straight to force of Y is equal to 44 newtons times the sine of 60 degrees.
Well, I did something wrong.
Can I just use Pythagorean theorem at that point?
Could, I don't like to because then you're using stuff that you've calculated. I like to use as little numbers that had to be calculated for as possible.
How did you get 22?
That's what it
I typed in 44 newtons times cosine of 60 degrees. Are you in degrees or radians?
I need to change it to degree feet.
Yep.
Who keeps changing these calculators?
Yeah. That's what I did.
I'm about to pull taken on. I will find you.
Okay, so in this, we find that force of Y for the second force we were given to be 38.1051 newtons. Now, we have to look at net forces. The components of the net forces. Now, when I'm saying the components of the net force, I'm not saying this right here. Okay? We're looking at a totally different situation. We're taking that, we have to find the net force between force 1 and force 2 so that we can find that third force to make it true for the net force to be 0. I'm going to say it again because I know it's a lot of information thrown at you really quick. We have to find the net force for force 1 and force 2 so we can change it direction-wise so we can find force 3 that will make the net force 0 newtons. Because that's what we're looking for. We're looking for that third force.
Will. Where you're gonna get money?
On this one, are we doing like kinetic friction?
No,
This problem?
because it's not sitting anywhere. Like if I have you, if it's not sitting on the ground, if it's not moving on the ground or anything, if it's not touching a surface, there is no friction.
Okay. Is when it's going up, is it always going to be sine? And then is it always going to be cosine? Or is it like switch up?
Depends the angle you're looking from.
So if you're like on the other side.
Look at it this way. It's kind of like Pac-Man. So go at the angle
Okay.
and make Pac-Man's mouth.
Okay.
Whatever Pac-Man's mouth is opening to eat, that's sine.
Okay.
Whatever is a part of Pac-Man's mouth, right here,
Yeah.
that's the adjacent, that's the cosine.
Okay.
I know it's weird, I don't know why, but that helps me.
It's like the alligator thing was greater than less than.
That's why I think it fits in words. Okay, so in this, when we're looking at the net force in the x direction, remember, this is just for forces 1 and 2. So we're not at a net force of 0 here. What is the net force in the x direction?
22 newtons.
But it is 22 newtons because there's only one force acting in that x direction. You don't see it acting, but it's here in this force that it acts.
But if those two, we would just add them.
You
Yeah.
just add them, which is where we go to the net force in the y direction.
So degrees times newtons equals newtons, right?
Huh? What?
Not technically. You've done a trig function there that got rid of the degrees.
Okay.
Leaves you with an actual value. That's unit circle stuff. I
Yeah.
seen someone make a
The
a
freaky
TikTok of that. I can't remember the guy's name, but it's from Ragnarok, and he's like, "Yeah, man, it's a freaky
Freaky
circle. Like,
Yep.
Anything that you think
That's
makes
what
sense
they
don't make
call
sense."
it in Cal.
And he, it's a trig teacher that was doing it. He was like, "Yeah, so we're gonna deal with a freaky circle, man. And it's all freaky and stuff. It's like anything that makes sense doesn't make sense." I'm like, "Yes." All right, so the net force in the y direction. What's the net force in the y direction? Remember, we're just looking at force 1 and force 2. What is it?
It is 71.1051.
It's 71.1051 newtons.
That's-
How did we get that though?
By adding
Adding those two forces that's
Y
acting in the Y
component
direction. So
and the
remember,
33 newtons.
this force is acting in the Y direction. You have to take that 33 newtons into account.
Oh, okay.
That's why I'm saying that's a separate force in red. This is why I do the different color pins. This is a separate force. So that 33 newtons plus this force coming from force 2 in the Y direction, we have to add to it.
Okay, you just put force, but is it okay if we put force Y, like?
The whole force Y, the net Y, net X, Y, it doesn't matter. It's whatever you want to label.
No, I mean like with the 33 newtons, so that we know that's in the Y direction, and we know.
It's whatever you want to label.
Okay.
Doesn't change. Oh, what do we get for that?
71.105.
All right. Now here's the fun thing. Let's find the component vectors for force 3. So this is straight up for force 3 that we're going to look at. What color have I not used? Where's my blue at?
Would that be on top?
What do you mean on top?
You said force What force is this?
Net force and forces 1 and 2 combined. Okay, I don't have my blue pen. I don't know what has happened to it. Someone has done it. It's probably laying up here somewhere. My mess. Okay, so we're going to do it in red. So in here, we need to find the components for the third force. You guys are going to love this.
Sure we will.
For force 3, X component. Anybody want to take a shot at what it is?
It's
Wait a minute.
the opposite.
I'm giving you a hint. You don't need that calculator.
Negative 23.
I'm not.
Newtons. Because why?
Because it's just an opposite direction.
It's opposite direction, but remember, you're at a net force of 0. Since you're at that net force of 0, that means everything has to cancel out. This third force is canceling all these forces acting up here. So we find the net forces of those acting. The components for that third force is equal to in magnitude, but opposite direction of it. So what about force 3 Y component?
Negative 71.
F net, negative F net Y.
F net.
F negative.
So it's at negative 71.1051 newtons. Or
What if
Connor,
it
you can say it that way as
wasn't
well.
0?
Do what?
What if it wasn't 0?
Then in that case, you couldn't be able to solve for this third force.
Okay.
Without me giving you the net force that's acting.
What if you
I could
gave
do
the
that.
net force that's active? Would you just add it?
What is it?
What if you gave the net force that's active? Would you just add
If I gave you the net force that's acting, then you would subtract the net forces from, that you got here from it.
Okay.
Figure out what the third force
That's
was.
what you did on the. There was a problem in the book that you gave us while there was this over here. Isn't that what we did?
I have no idea. I don't
Pretty
get
sure
that
it was
memory.
like the 40 minus.
So now in this is what we have to do now.
Pythagorean theorem.
We can do the Pythagorean theorem real quick. You guys want to do that?
Oh.
Yeah.
Okay.
Do it.
So in this, to find the true force of 3, it's equal to the square root of,
This
The
is
negative-
Pythagorean theorem.
it is Pythagorean theorem.
This is one freaky Pythagorean theorem.
Thomas, instead of squaring your stuff first.
You want me to call that C?
Yes.
You just flipped the whole thing around.
C
That's
equals the square root of a squared plus b squared.
that's horrific.
No, it doesn't. It's a squared plus b squared
Equals
c
c
squared.
squared.
But then when you
And then you take
Take the square root of C.
all of them.
What do you get?
Yeah, but this is too complicated.
Don't it all just cancel out?
Yes, it's all just the same. No,
No, because you
Are you
have to
messing with
add
me
them.
right now?
it doesn't cancel out because you
You
can't
have to
set.
add them
That's
before you
why
take the
that's
square
what-
root.
Yeah, you can't set. You can't take
You
that
do
square
it
root.
your math way. It's fine. I just joked
because
I'm
of
just
the.
trying to
Just
save
square root.
time.
It's just square root.
Hey guys, it's just square root. Everything cancels.
squared
Everything cancels. But
plus b squared.
I like that little hook you put on him, Mr. Hall.
I don't know what I was talking about.
Equals c squared.
Okay, well, I got a freaky answer.
Like a freaky circle.
Freaky circle wasn't this freaky.
And then
That ain't no good though.
once you do
No dice.
22.
There we go. Dude, you're adding them together, it doesn't matter.
we're going that far.
Hold on. Mr.
So,
Oh
What?
my goodness, that's
which out of the way? What'd you get?
But I'm not quite there yet.
Yeah, you just went back to negative.
Yeah, I was,
74.
because I put the direction with the degrees. Or well, I would put it there.
Okay, thank you. Hi, Kevin.
My stinking calculator has decided to bite the dust.
No, you know what you're doing? It's that good old negative you're putting in there.
Took it out.
With did it?
I got 74.
I'll see.
I did too.
It is 74, but I want to figure out why my calculator is not wanting to calculate it.
Maybe you should get your new calculator.
Just
Maybe you should
reset
turn
it
the
off.
Mac away.
Yeah, you said it.
I did reset it. Let's see if it
Second
fixes it.
and reset one.
Sometimes you just need a reset.
Did it work?
Yep. I want to see if it'll do it this way, because this shouldn't matter. In terms of math, I'll do it the math way.
Oh my goodness, I still got it wrong.
Stupid. All right. Anyway, get 74.4307
Okay.
newtons. Now, if you're wondering why there ain't no negative there, I'll tell you why there's not a negative there.
Because you have your
That's
direction.
magnitude. I don't have to have magnitude, but this is the thing here. We have to get the direction of this. So now we're looking at direction. That's angle. Because remember, we're in 2 dimensions.
Why would you have a negative anyways? I didn't have a negative.
You should. But if you look at it this way,
You're sick. You go home.
I'm not sick. Don't start that rumor.
Say, Mr. Howard needs to go.
I'm get so ticked if some kid starts that rumor on me and I have to go get a stupid doctorate
They
note
like
saying
video
I
you
don't
like
have
call.
COVID.
Right to the office to tell that you was calling.
All right, so in this,
He needs to go home, he's got COVID.
in the X direction, we go over 22 in the negative direction. How else you gonna get the angle?
Are we just making a...
Triangle, so we can find the hypotenuse, which you done did. Does everybody want to jump there? Now you're going to go down negative 71 point, well, you're going to go down 71.1051 newtons because that's the direction, negative direction for y.
Whoa.
So 71.1051 newtons. And we get this right here
I got it
is our hypotenuse, which you guys decided we just solved for, which is 74.4307 newtons. But along with this, to get the correct answer, you have to have the angle. What angle are we talking? Right here's your right angle.
90.
We want the one that's right here at this x-axis.
60.
How do you know that?
60.
Because it's adjacent.
I
Yeah.
disagree.
Because 90.
No, it's 30.
So
Mr.
that's to
Hall,
add up to 180 degrees.
Isn't it 30?
180 degrees minus 90.
I get where you're coming from. That was 60.
90 degrees.
Can I say
Hey,
that
guys.
it
That
would
was 60
be
there.
30?
You had a second force to take into account.
uh,
Don't just assume
okay.
that you're going to go opposite of that. We never figured out the angle for these.
But I did.
Now, if you wanted to figure that angle out, you could, and then you could just go opposite of it. Okay?
Wait.
Like, you'll be given problems. I'll give you problems to where, like in this case, I'll give you all of these forces. You have to find the net force, and you can find that angle it's at, then you just flip the angle.
I'm
It
really
works
getting
perfect.
tired.
So in this, you're still not done once you find theta. I labeled that theta, that angle. We also, you have to come all the way around.
Is this where we have to use the opposite and
I'm going to call that beta.
Beta.
We have to have beta. You can't just do theta, because theta is a reference angle.
have we done?
We can find theta, and then from
Yeah.
there we can use that you're right there adjacent to, say, full 180 degrees, but you first have to find theta. So in this case, if I did, this is how I would do it.
Didn't we already find theta? Well, I already found theta. Never mind.
Like the brag, don't you?
That.
Tan of theta
No, I
is equal
thought,
to opposite,
I
which
thought
is
we'd already done it up there.
71.1051 newtons divided by adjacent, because I'm doing the tan, which is 22 newtons. I'm trying to find theta. So to find that, we have to do the inverse function. So theta is equal to the inverse.
Now, why would that be 71 and not negative 71?
Because it doesn't matter apparently.
Yeah, because we get the direction with our
You're
degree.
doing it. Can length be negative?
No.
No, I'm looking at a triangle right now. I'm not looking at force.
Now, wait, what?
Okay, building a triangle that has a negative length in it.
Not
You can't.
negative. Can't they?
No.
No, lengths of a triangle cannot be negative.
Oh, okay.
The direction you went with it took care of the negative sign. That's why where I went down, that was the negative sign in that case. So 71.1051 newtons divided by 22 newtons. So
Okay, you have to do the.
min degrees, second, tan.
Wouldn't that kind of be like if you have
I got 72.8079 degrees. That's theta. We have to find beta, which goes all the way around to that line. Beta, just another Greek letter, is theta plus 180 degrees. Which will be equal to 72.8079 degrees plus 180 degrees. I'm just leaving that number that I just calculated in my calculator. I'm just going to use the answer.
so you're trying to
plus.
find the point of this line basically, or this force, whatever it is.
I'm finding the direction.
So we always have to find
So-
the theta. After.
Not in all cases. If you're in the first quadrant, no. It's 252.8079 degrees. So in that case, that means force 3 is equal to 74.4307 newtons at 252.8079 degrees. How'd you take 4 sheets?
That took like 2/3 of a page, Mr. Hall.
He just writes
Bam!
Although it did take
Perfect time.
multiple
Questions? Wait, is that perfect timing or the bell still off?
good.
No, it's
It's
Yeah.
perfect timing.
They got fixed. Questions? Good deal. I will see you tomorrow, where we will pick up on number 82.
Yeah.
Whoop whoop.
Coming soon, class near to you.
You know what you're doing.